Welcome guys to another video. Today we're going to take a look at our independent practice problems for exponentials and logarithms, specifically targeting their equations. Okay, so I'm going to work a few examples and I will show you the worked out examples of a couple more problems just so you have extra reference. Okay, so you can see I have the problem numbers and page numbers listed here. You can also follow along with me on the following slides. Okay, so this is problem 39 on page 51, and we see that there's $1,000 target amount that we're looking for, which is our final amount in a savings account, and it has an interest rate of 5.75 compounded continuously over 3 years. Now, they gave us the formula, but you should kind of already know that this is the continuous compounding formula. And so in this case, since we have our formula, let's fill in the details. Just be careful. The 1,000 in this case is actually the a value of this equation and not the initial amount, not the p value. So we have 1,000 equals p e to the 0.0575 power times 3 years up there. Okay, so that is very important that we nail that formula. And so to solve this equation that we've set up, what we're going to do is we're going to take this e to the 0.0575 times 3 and divide it over. So I'm going to have something like this. P equals 1,000 over e 0.0575 times 3. And that's now in a form I can punch in my calculator. And if you punch this in, you will get that your starting amount needed is going to be $841.56. And don't forget, we should be rounding our money to two numbers after the decimal point. Okay, so as we take a look at number 40, guys, just go ahead and pause the video and try yourself, and you can compare against my answer that I'm going to show you. Okay, here you can see I have worked the problem out for you using that same continuous interest formula, A equals PERT. And this time, since I was solving for time, you'll notice down here in blue, I had to take the natural log. So once I have the e piece by itself, I take the natural log to help me get that exponent by itself and come to the conclusion that the time it would take is 2.515 years. Okay, so here's problem 51. And it's not really a fancy problem. They ask you how much interest do you receive after a year on a single dollar deposited based on the way it's compounded, right? So we're going to use that compound interest formula. Let's take a look at how it's set up. Okay, so part one says, how about if you compounded this 12% quarterly? So again, I'm going to say A equals P 1 plus R over N to the NT power. And so for part A, I'm going to say, okay, I'm depositing $1 at 1 plus 0.12 over 4 to the 4 times 1 power. Okay, and so basically you can simplify it by hand. You could also just go to your calculator to calculate what this is. And you should come up with, I'm going to go an extra couple decimal points just to make sure it's pretty obvious the differences. 1.1255. Okay, and if you can do the other two parts of this very similarly, compounded monthly and compounded daily. Okay, I'll go ahead and set them up and show you what they are as well. So here you can see our results for quarterly, monthly, and daily. And you can see as you compound more often, the value does increase, but it is very marginal after a certain point. Okay, so problem 42, okay, and this one I'm just going to work out for you guys and you can check your work against mine. So go ahead and pause your video. And so here is my worked out solution for this problem. Just do be wary of the fact that since we're solving for the time, which is in the exponent, I did have to rewrite this as a log. I did simplify my 1 plus 0.06 over 4 to 1.015, and that is just to make it easier for you to punch in the calculator. Okay, the 7,500, in case you are Not sure. This is the starting amount tripled, okay? So that is 2,500 times 3, and y, when we divided it, we got 3 here, okay? Awesome. Let's take a look at a half-life problem, okay? So how many days does it take for 16 grams of palladium to decay to 1 gram, okay? The half-life is going to be 17 days. Now, half-life formula looks something like this, okay? My current amount equals my starting amount. Sometimes that P is also written as an A0, which is the starting amount, and it's going to be times 1/2 to the time divided by the half-life. Half-life is sometimes denoted as H and sometimes denoted as K, but both of them mean the same thing, just how long the half-life is, okay? So in this case, it's not going to be super crazy. We're just going to fill in the information we know, solve for the missing piece, right? So I want to end with 1 gram, and I'm starting with 16 grams, okay? We got our 1/2 constant base. My time is what I'm looking to solve for, and my half-life is 17 days. Okay, and we can manipulate this fairly easily. Divide by 16, and then take the log of this to help us solve it, right? So let's do log base 1/2 of 1/16 is going to equal t over 17, okay? And my final step before I punch it in the calculator is going to be to multiply by 17. So we'll get something like this. 17 log 1/2 1 over 16 equals t. And then we'll go to our calculator and punch it in. And you should come up with that it is 68 days. Okay, and so that is how you can calculate that half-life time. Here's another growth equation where we're going to solve for a missing piece. In this case, we're solving for a constant k, but they give us the formula, and so it's a lot of just filling in the information and solving for it. So go ahead and try to fill this in and solve it, and then I will show you my answer. And you can see now my solution is here. And so just keep in mind, since I had an e in this problem and I took a log, I wrote it as natural log. Okay, that is log base e. Okay, this last one is a fun one. Okay, so it looks kind of complicated, but it's actually very simple as long as we remember our log rules. So we have k to the log k6 power and log m to the m negative 4 power equals to x. Well, the key thing to remember in a problem like this is that logs and exponents are actually inverses of each other. Okay, and so using that, we can actually quickly solve this problem. So first, this one, k to the log k power, those actually cancel each other out. This term is actually just equal to 6. And similarly, even if you take this and move this negative 4 out front, you realize that log m of m is just equal to 1. So you get 6 plus negative 4, which is equal to x. And you're just like, okay, well, that's just 2. So that's my answer right there. It's actually a very simple problem coming out of something that looks pretty confusing. Okay. Hopefully, guys, these problems help you out. Good luck and happy studying.